Let's discuss this example. So in this example, we have a matrix space XD and they have defined one matrix D1 with the help of D, which is in this way. D1 of xy is equal to D of xy upon 1 plus D of xy. What we have to prove? We have to prove that these two matrices D and D1 are equivalent matrices. So you know our technique to prove that any two matrices are equivalent. We prove that every D open ball contains D1 open ball and every D1 open ball contains D open ball. This is a very simple technique we are going to use here. Okay, so let us start. So I am taking one arbitrary point, let x belongs to capital X and r greater than 0 be given. Okay, r is any positive real number. Then BD XR is D open ball. Okay, so we have taken one point, we have taken radius, so we got D open ball. Okay, so we have to prove that this D open ball contains D1 open ball. So for that purpose, I am selecting one radius. R1 is equal to R upon 1 plus R. In this way I have defined. R is positive, so if you add 1, if you take a ratio, we will 100% we will have positive real number. So R1 is also positive real number. So now we will prove that. See what we will prove. We will prove that D1 open ball XR1 is subset of D open ball with center X radius R. So in this way we are going to prove that this D open ball contains D1 open ball. Okay. So how to prove one set is subset of other? By selecting one point from this set, I will prove that it is in second set also. Let us follow this technique. Let y belongs to this D1 open ball. Okay. See, we have some space here. Let us use. This point lies in a ball. That means distance of this point from the center of ball is less than its radius. So that's why what can we write? So therefore distance, okay, D1 distance between x and y is less than, see, this R1, okay, less than R1. See, but what is definition of D1? Definition of D1 is this one. Let us use it. So definition of D1 is D of xy upon 1 plus D of xy less than R1. What is the definition of R1? R upon 1 plus R. Let us put. Can you guess what I am going to do now? I am going to cross multiply. All numbers are positive, so no need to worry about that inequality. Let us cross multiply. D of xy into 1 plus R, that means D of xy plus R D of xy, right? Less than this R into 1 plus D of xy, that means R into 1 R plus R D of xy. So this is left hand side, this is right hand side. See, one term is common between left hand side and right hand side, that is R D of xy. So we can cancel R D of xy from both sides and we will have D of xy less than R. Getting? So distance between x and y less than R, that means y belongs to D open ball with center x radius R. Basically, we had taken y from D1 open ball and we proved it is in D open ball. So that's why this D1 open ball is subset of D open ball. So therefore, this D1 open ball I will write here, which is subset of this D open ball. So in this way we proved that every D open ball contains D1 open ball. So now our task is to prove every D1 open ball contains D open ball. We are going to do it, but before you can make a screenshot of it. See, now we have to prove that every D1 open ball contains D open ball. So here I have considered one D1 open ball by selecting one point X and radius S1. Okay, so this is our D1 open ball. We have to prove that this ball contains D open ball. So for that purpose, I am going to select one radius. So let I am selecting S. It's same as S1, same as S1. Getting? So S1 is positive, so obviously S is also positive. So we will prove that. I will mention. We will prove that. See what we are going to prove. This D open ball with center X radius S subset of this D1 open ball, center X radius S1. How to prove that one set is subset of other? By selecting one point from first set, we will prove it is in second set. Let us do, let y belongs to this D open ball, okay. So y belongs to this ball, that means distance of point from the center of ball is less than its radius. So that's why D of xy less than s, okay. So this implies d of xy divided by 1 plus d of xy. See what we are doing? We are dividing d of xy by one more number. So obviously it will reduce the value of d of the actually term. Getting? So d of xy upon 1 plus d of xy less than or equal to d of xy. Since if you divide by any positive number, getting, and which is greater than 1, that means 100%, it will be less than that one. Getting? But see, d of xy is less than s. So we write this is less than s. So see, we know that a less than b, b less than c. So that's why a less than c. So what can we write here? So therefore d of xy, okay, upon 1 plus d of xy, that is less than s. So d of xy upon 1 plus d of xy, this is nothing but definition of d1. So therefore we can write d1 of xy, and this is less than s1, since s is nothing but s1. So therefore distance between x and y is less than s1, therefore y belongs to open ball with center x, radius s1 with a metric d1. So basically we had taken point from d open ball and we prove it is in d1 open ball. So therefore what can we write? Therefore open ball with center x, radius s, subset of open ball in D1 with center x, radius S1. Getting? So in both way we proved. So therefore we can declare D and D1 are equivalent matrix. So therefore D and D1 are equivalent matrix. Equivalent matrix. Yes, in this way we completed this example. Make a screenshot of it. After that we will stop. Thank you. Bye bye.